How many people here recycle at home? Oh, good number. What kind of things do you recycle? Erica?
Glass and cans.
Glass and cans. Katie?
We can have soda cans recycled.
What do you recycle?
Paper.
Paper.
You can recycle jugs of milk, the plastic ones.
What about food? Can you recycle food? So what happens to your food after lunch in the cafeteria if you don't finish it all? What happens to it? Rachel? Goes in a garbage can. Yes? Goes to the dump.
If you're like most Americans, you generate close to 4.5 pounds of garbage every day. This adds up quickly. In the United States alone, we produce 222 million tons of garbage every year. As the population grows, so does the amount of garbage. The EPA estimates that by the year 2010, this country will have to deal with 265 million tons of trash annually. So where does this garbage go? Some of it gets incinerated, some gets recycled, but 60% ends up buried underground and covered with dirt in disposal sites known as landfills. For years, landfills have been the most popular waste disposal method, but time may be running out for this solution. Many landfills are filling up quickly, and new space is hard to find. In the U.S., and especially in countries with a smaller landmass like Japan, governments have tried to burn the waste, but this solution is expensive and releases dioxin and other poisons into the air. We have to find other solutions for waste disposal. Even a medium-sized city can produce tons of trash every day. The largest component in a landfill is paper, followed by yard waste, glass, and metals. The next largest component is food waste, at roughly 11% of all waste generated. This food waste is an especially troublesome element of the landfill. As it starts to decay, it gives off odors, dangerous gases, and attracts rodents and other animals. We can't eliminate all the waste we generate, but we can all do our part to create less of it. We throw away 14 million tons of food every year. To put that into perspective, if you were to take all that and heap it up onto a football field, you'd have a pile 43 miles high. That's about 6 times the height of Mount Everest, the tallest mountain on Earth. Because of the way that landfill technology works, this material never has a chance to completely decompose. It's dumped on the ground and immediately plowed over. This deprives it of oxygen and the elements that would normally break it down. In fact, there are researchers who have studied landfills, and they've reported finding a 20-year-old head of lettuce perfectly intact in the middle of a city dump. The real irony is that this garbage can actually become a valuable resource for gardeners and farmers throughout the world. When the waste is properly composted, it breaks down into a valuable organic soil additive that provides nutrients for crops and flower gardens. And that's why we're here today, to tell you about a special form of recycling that uses microorganisms. Microorganisms are tiny units of life, too small to be seen without a microscope. They're everywhere in nature, in the air, soil, ocean, rivers, animals, and even in the human body. When we hear the word microorganism, we usually think of the kind that are harmful, like the virus that gave you the flu last summer, or the bacteria that caused an infection or spoiled that food in the back of your fridge. Microorganisms are the reason mold builds up in a bathroom, or a trash can smells bad on a hot day. These not-so-friendly guys of the microbial world are called pathogens. However, the vast majority of microorganisms don't cause this kind of damage, and in fact are crucial for sustaining life on Earth. This very friendly group is known as beneficial microorganisms and are responsible for balancing the Earth's ecological system and carrying out chemical processes that make life possible. In fact, without bacteria in our bodies, we wouldn't even be able to digest our food. In 1982, Dr. Teruo Higa, a professor of agriculture at the University of Ryukyu in Okinawa, Japan, made an amazing discovery while conducting research on the beneficial effects of microorganisms in agriculture. Dr. Higa discovered a specific group of naturally occurring beneficial microorganisms with amazing antioxidant and anti-putrefactive properties. What does that mean? Instead of having food waste rotting and stinking, These microorganisms have the ability to revive, restore, and preserve. Instead of studying the effects of one of these microorganisms at a time, Dr. Higa discovered that a combination of different microorganisms was most effective. For the next several years, he kept experimenting with various mixtures and eventually developed a combination of microorganisms from 5 separate families that seemed to work best. The 3 most important groups of beneficial microorganisms in EM are lactic acid bacteria, yeast, and photosynthetic bacteria. These products are all used in food production today and are on the government's list of products that are generally recognized as safe. Lactic acid bacteria are used to produce cheese and yogurt. It turns cucumbers into pickles or soybeans into soy sauce. It is also produced in our bodies. It is lactobacillus that helps our food digest. Yeast is used in making bread and wine. Lactic acid bacteria are used to process foods like Swiss cheese. It keeps food from smelling bad. It is also used outside the food industry, for example, to control algae and odor in fish ponds. This combination of effective microorganisms had an amazing effect on crops when it was tested in the fields. Not only did crop production skyrocket, the plants were healthier and more resistant to disease and pests, and the treatment eliminated the need for dangerous pesticides as well as the use of expensive chemical fertilizer. Although Dr. Higa's research initially concentrated on agricultural uses, he soon found other ways to use this EM. It turned out to be effective at fighting different kinds of pollution, and it changed the way food waste decomposed. Normally, garbage combines with oxygen and putrefies, or decays. The doctor mixed the garbage with these effective microorganisms in an anaerobic condition, which means that no oxygen could get to it. And instead of a smelly, rotten mess, the garbage fermented. Fermenting is the same process that turns cucumbers into pickles or grapes into wine. As he conducted further research, he began to realize some wonderful potential benefits from this process. When he buried the fermented waste, it turned to rich, nutritional compost in a fraction of the time that it normally takes. Since the garbage was already fermented, it didn't rot, it didn't smell bad, and it provided an opportunity to transform a giant problem, tons of food waste, into something that could benefit the entire community. With these goals in mind, Dr. Higa formed EM Technologies, a nonprofit organization, to help other people learn about the possibilities he was discovering. Today, this technology is being practiced in over 80 countries worldwide. Millions of tons of garbage have been diverted from landfills and turned into rich, healthy compost. EM has the potential to reduce pollution and the amount of chemicals in our environment, help solve waste problems, and promote better food production. There is even research going on into the medical possibilities of EM technology. Before we explain how to get a program started in your school or home, let's talk about how this process actually happens. Food waste is made up of organic compounds. That means, in general, a complex molecule containing many different elements, including carbon. In its whole form, these molecules are no good to the soil, but as they decay, they break down into elements like nitrogen, phosphate, potassium, and minerals that are essential for growing plants. Now, in a normal composting operation, it can take months for materials to break down into elements. You start with organic material. As it starts to decompose, it gives off energy in the form of heat, sometimes as high as 150 degrees Fahrenheit. It can also give off energy in the form of gases, which in some cases can make the process smell and attract flies and rodents. Finally, after 6 months to a year, the material is broken down into its basic elements: nitrogen, potassium, phosphate, and so on. From there, the plant absorbs these materials through its root system and converts it into the enzymes and amino acids that it needs to live. Throughout this process, the compost is giving off energy, and that means it's losing nutrients. The end product has less nutrient content than the material you started with. The EM technology method of composting streamlines this process. It happens over a period of about 4 weeks, start to finish, so you see the benefits much more quickly. In the first step, the material is fermented, which helps preserve it. This fermenting process takes about 2 weeks. It may help to think of a cucumber. If you leave it sitting out on a shelf, it will rot and start to smell in a couple of days. But if you put it in a jar of vinegar, it turns into a pickle and will stay fresh for months. Once the material is fermented, you dig it into the ground. Over the next 2 to 4 weeks, the compost will break down, but there are some big differences. The entire process from here only takes 2 to 4 weeks. No significant heat or gases are produced, meaning very little energy is used up in the process. Since very little energy is used during the process, the EM compost has a much higher level of nutrients than the traditional method. Also, the material doesn't break down quite as much as it does in regular composting. What happens is that it breaks down into smaller molecules, like amino acids and enzymes, that the plant can use right away. These compounds stay together because of the fermenting process that happened in step 1. In 1996, EM Technologies formed the Bokashi Network, a nonprofit group dedicated to teaching the concept of sustainability in schools. These programs give students a chance to establish a connection between the soil, the ecosystem, and their role in improving the quality of the environment.
EM Bokashi Network Recycle 운동가盛んになって
I am very happy to hear about the activities of the EM Bokashi Network in Tucson, Arizona. As we live our daily lives, we all pollute our environment. As economies expand, the environment suffers. Therefore, it's vital for us to have an awareness of environmental issues. Each of us should do our part in helping to clean the environment. EM can help clean up the pollutants that are the main causes of environmental pollution. If we use EM, even food waste becomes a valuable resource that can be recycled back into the soil, producing healthy flowers and vegetables, cleaner air, and revitalized soil. I believe that if people of all ages use EM, it will play a vital role in cleaning our environment and improving the quality of life. I am so grateful to hear that the EM Bokashi Network outreach program based in Tucson, Arizona is rapidly expanding throughout America. I believe the EM Bokashi Network grassroots movement will play a leading role in improving the quality of our environment. I really hope you enjoy participating in the EM Bokashi Network.
Think about how much food is thrown away in your school every day. There's all the food that isn't eaten from the trays, plus all the leftovers the kitchen doesn't serve up. Try to imagine if they piled it up in the corner of your classroom every day. It wouldn't be long before you were looking for new classroom space. We're going to show you how to start a food waste recycling program in your own school and at home. We'll start with a home program, which will show you the basics of EM composting, and then talk about how to get a program running in your school. Composting with EM is a simple and down-to-earth process. First, you mix the kitchen waste with the compost starter. Second, you give the waste some time to ferment. And finally, you transfer the waste into the garden or planter. We'll go over each step in detail to get you started on the right path. You'll need 2 or more EM composters, or you can build your own using any 3 to 5 gallon plastic bucket. If you build your own, make sure it has the following features. First, an airtight lid. If too much air gets into it, it could spoil the process. The buckets will need a strainer or divider to separate the food waste from the liquid that will accumulate during this process at the bottom of the bucket, and it will need a spigot or valve to drain this liquid. You'll also need some EM Bokashi compost starter. You can make your own or purchase it from EM Technologies. Later on, we'll make Bokashi together. And of course, let's not forget your food waste. Just toss your leftovers and food waste into the bucket after each meal. If you have anything big like melon rinds or carrots, you can chop it up into small pieces, nothing bigger than the size of a golf ball. This will speed up the process. What kind of food can you put into the bucket? Well, just about anything you eat. Fruit, vegetables, cooked or uncooked meat, and fish, prepared foods, and dairy products like cheese. Never add any spoiled or moldy food items or any liquid such as milk or juice into the compost because it can spoil the batch. Don't add plastic, glass, styrofoam, aluminum foil, plastic wrap, soda cans, or paper products. When you're ready to start composting, spread a handful of EM Bokashi over the bottom of the pail. Next, add your food waste and coat it thoroughly with a layer of Bokashi. A good rule of thumb to follow is to add 1 handful of the compost starter for each inch of material in your bucket. Use more Bokashi during the summer or when treating high-protein foods such as meat, fish, and dairy products. Mix in the Bokashi every time you add garbage. You don't have to stir all the way to the bottom of the bucket. Just mix it with the garbage you've just added. You should end up with layers of each day's mixture in your bucket. If you're just tossing in a little waste, sprinkle a little of the bokashi over the top and give it a quick stir. Close the lid tightly every time you add waste to the bucket. Remember that EM needs an airtight environment to do its job. It's probably easiest to store the bucket right in the kitchen. If it's tucked away somewhere, it may be too hard to get to on a regular basis. Just make sure it's not in the direct sunlight. Keep adding new layers of garbage and the compost starter every day until the bucket is mostly full. During the fermentation process, liquid may collect at the bottom of the bucket. The amount collected will depend on the type of food waste you add to the bucket. Fruits and vegetables tend to release more moisture than other foods. It's important to drain this liquid frequently, at least every other day. You'll want to save this valuable liquid, which we call garbage juice. It can be used to fertilize your houseplants and garden and to control odors in drain systems. As a fertilizer, dilute it to a ratio of 1 to 1,000. This is equal to 1 teaspoon of garbage juice to 1 gallon of water. Pour it onto the ground surrounding the plant, not on the leaves themselves. You can also pour the undiluted solution down your sinks, drains, or toilets to prevent slime buildup and odors. Just be sure to use the EM garbage juice the same day you drain it, otherwise it could spoil. When the first bucket is full, store it away from the light for about 2 weeks. Get out your second bucket and start composting your fresh garbage in it. Remember, you'll want to keep draining the garbage juice every 2 to 3 days. After about 2 weeks, the first bucket should be done. The best way to tell if everything has worked out is by the smell. As you remove the lid, you should notice a sweet and sour, slightly acidic smell, like pickles. There may be some white mold or yeast growing on it. This is a good sign. If you notice a bad smell when you take off the lid, something has gone wrong. The mixture has putrefied. Some of the things that can cause this failure are not closing the lid tightly after every use or not having an airtight container, failure to drain the garbage juice often enough, not adding enough bokashi, using poor quality bokashi, adding spoiled foods to the compost, or too much exposure to sun or extreme temperatures. But for now, let's assume that everything went well and you have a good batch of fermented garbage. The final step is to transfer it to the garden or planter. There are several different ways to do this. In a new garden where nothing is planted, dig a hole 6 to 8 inches deep. Pour the contents of the bucket into the hole and mix it with the soil. Cover this with a 3-inch layer of just soil. You can also use a planter or container. Make sure you get one with drainage holes in the bottom. Start with a layer of gravel. This will help the drainage. Add 1/3 potting soil, 1/3 fermented food waste, and cover with 1/3 potting soil. Now with both of these methods, you will have to let the waste continue fermenting for at least 2 weeks before planting anything. Trenching is a good way to deal with a large amount of waste. Schools, restaurants, and businesses can use this method. Dig a trench 2 to 3 feet deep and 1 to 2 feet wide. Pour your waste into the trench and cover it with a layer of soil, about 6 inches. Keep adding layers until the trench is full. Wait a month to either plant directly on top of the trench, or you can dig out this super soil and use it in your planters or in your garden. You can also use the compost to fertilize existing gardens. You want to dig in between the beds 6 to 8 inches deep, keeping your hole about a foot away from the nearest plant. Add the fermented garbage, mix it with the dirt, and cover it all with 3 inches of soil. Make sure the roots of the plant don't touch the compost directly. For trees, dig holes about 1 foot deep around the drip line. This is under the end of the longest branches. Bury the fermented food waste in the holes and cover with 3 inches of soil. Again, make sure the roots do not come in direct contact with the compost. Now, what if something went wrong with the fermenting process and you end up with a gross, disgusting smelling bucket of garbage? Don't throw it away. You can still use it. Dig a hole 1 foot deep and away from trees and plants, or use a 10-gallon planter. Spread a half a pound of bokashi in the bottom of the hole. If you're using a container, start with a layer of soil, then add the bokashi. Put in the contents of the spoiled bucket and add another half pound of bokashi. Finally, cover it with a layer of soil. In the summer, this will take about 2 weeks to break down, and about a month in the winter. In a new garden, wait about 2 weeks and plant your flowers or vegetables. Take care of them like you normally would. Make sure they get enough water and sunlight. Normally, they won't need any extra fertilizer with the EM compost in the soil. The EM compost helps develop a nutrient-rich soil that helps everything grow better. Flowers will grow bigger and last longer. When used to grow food, EM can increase crop yields, produce food that is more nutritious and tastes better, and food that even lasts longer once it's harvested. And all of this from a program designed to get rid of garbage. That's really one of the best things about EM technology. Solving one problem leads to solutions for other problems. Let's look at a school where this program has been going on for a while. Miles Exploratory School in Tucson, Arizona started an EM recycling program in 1996, and they've already diverted over 7 tons of food waste. The school has won numerous awards for both their food recycling efforts and the beautiful gardens they have planted using the EM compost. So how do you get a program started in your school? First of all, get a lot of people involved, classmates, teachers, and maybe even parents. This will mean less work for each person, and it's always more fun to do things as a group.
Get as many adults and family members involved as possible, that they will help support the program. Get the neighboring businesses involved so you can recycle their containers.
Next, you want to set up a coordinator, someone who's in charge of the whole project. This can be a teacher, cafeteria worker, student, parent, or outside volunteer. In large schools, you might even consider creating an outside paid position.
The students totally took over this. In fact, so much so that I don't even know where some of the things are, but the Bokashi is always there ready to use. They put up the list in the classroom, they sign up themselves, they know when to leave the classroom, come over, set it up to it. I actually have moved into the position of really having very little to do with running it once they're taught at the beginning of the year.
You'll need to look at some logistics. That means figuring out how things will work. You'll need to find a place to collect the waste and store it as it's fermenting. Figure out what you're going to do with the compost. Will you start a school garden, or is there one already? Is there a neighborhood garden or farmer nearby who can use it? For some schools, it's easier to start on a small scale, recycling once a week, or just in 1 or 2 classes to start.
Start very small, something that's manageable. If you start too big, you're going to be overwhelmed. So start with something that you're comfortable with and that you can, that doesn't overwhelm you. Like we started just collecting with 1 meal. And now we're collecting 1 meal but 3 stations, and we've picked up a restaurant that we're collecting at now. So you have to start small.
You'll have to figure out how many buckets you'll need and make sure you have enough EM Bokashi compost starter on hand before you begin. Keep in mind that it will take 2 weeks for each bucket to complete the process. This means that if you collect 3 buckets every day of the week, you'll need storage space for 30 buckets. The mixture should be kept in a dark place, or at least out of direct sunlight. It will be easier to drain the buckets if they are placed on cinder blocks or wooden pallets off the ground. You'll also need to set up a schedule to detail who will do what work, from collecting the food waste, checking to make sure the garbage juice is drained on a regular basis, and who will be working in the garden. Again, this is easier when you have a lot of people involved. After you know what you're going to do, but before you start composting, you'll want to send home information and have a meeting with anyone who is concerned. Parents can get worried. When they hear the word microorganisms, they tend to think about things like the flu virus or the E. coli bacteria that can infect food. You're not dealing with anything like these in the EM process. All the microorganisms are on the Food and Drug Administration's list of items that are generally recognized as safe. You want to assure them that this is a safe process and answer any questions they have before you get started. From here, the steps are pretty much the same as in a home composting setup, just on a much larger scale. You will need to have a place to collect the food waste. Normally, this is easiest where students return their cafeteria trays. You may already have separate containers for cans and recyclables. What you need to do is add another container for students to scrape their food waste into. The best way to do this is to scrape the food directly into the fermenting buckets and add the Bokashi as you go. You can add the same types of food you used in the home demonstration. Just add a handful of Bokashi each time you get another inch or so of food waste in the bucket. It's better to use too much Bokashi than too little. If you have any doubts, use a little more. When the bucket is full, add 1 last layer of Bokashi, seal the lid, and move on to the next one. After the breakfast or lunch period, you can add the leftovers from the kitchen side of the cafeteria. As you fill one bucket and move on to the next, be sure to put a date on the full one so you can keep track of it. It should be ready in about 2 weeks. Store the filled buckets in a place that is protected from the direct sun or extremes in temperature. Keep checking the liquid and drain it every 2 to 3 days. After about 2 weeks, the fermenting should be done. Remember to check the smell as you lift the lid. It should have a sweet, sour smell. Take the compost out to wherever you've decided to use it and dig it into the soil using one of the methods we talked about earlier. For schools with a new garden, trenching works pretty well, and you can also use it to fertilize an existing garden. When you dig this compost into the soil, you're introducing millions of these beneficial microorganisms into the soil. There are already millions of microorganisms in any handful of soil, including some of the ones that come from the compost. Our research shows that what you are doing is tipping the balance in favor of these effective microorganisms. They sort of crowd out the more harmful ones through a process called competitive exclusion. Well, we've covered a lot of ground here and given you the steps that have worked for most schools in our program. Remember, what you need to do is find the system that works best for your school, especially in terms of volume of food collected. One area we still need to talk about is how to make bokashi. As we mentioned earlier, you can purchase it directly from EM Technologies. Many schools have found it more economical to make their own. We'll take a look at how the Arizona School for the Deaf and Blind has set up their recycling program. ASDB is the first school in the nation to implement an EM vocational program with students making bokashi for use by people who live in the community.
The first year all we did was collect. The next year we learned how to make bokashi. The next year we are now making compost and soils, and then we're gardening. So you have to make sure that you start small and then build upon one step upon another step so that it's done comfortably.
To make 4 pounds of bokashi, you will need 4 pounds of wheat bran or rice bran, 1 quart of non-chlorinated water, 2 teaspoons of molasses, and 2 teaspoons of EM mixture. You can get wheat bran at a feed store. In most communities, the tap water has chlorine added to kill any harmful microorganisms. Unfortunately, they also kill the beneficial microorganisms, so you'll have to get some distilled or other non-chlorinated water. Any kind of store-bought molasses is fine, and of course, the EM mixture will come from EM Technology.